Okay, question number 3. This question asks us to determine the minimum requirement diameter of the brass shaft and the aluminum shaft. So this is the diagram. So for this case, we have to do two cut section. You're able to see here, first cut is over here, the second cut is over here. So let's go to cut segment 1. This is the first cut segment. It is an aluminum shaft. You're able to see here two torque at C and torque at CB. Torque at C is positive upright. I use the right hand rule. Another one is torque at CB. I assume it to downwards. By using the summation moment at X, you're able to find the value of torque CB, which is 23,000 Newton meter. By using the torsion equation, you're able to find the radius of the aluminum shaft. Make sure you use the right maximum shear stress because they are given two different maximum shear stress according to the type of shaft. For aluminum shaft, they give the 90,000 megapascal. So later you will get the radius 0.0546 meter. By substituting the value, by calculating, you're able to get this value. From here, you have to times 2 with the value to get the diameter of aluminum shaft, which is 0.1092 meter. Okay, now let's go to cut segment 2. Here you're able to see again two torque. One is torque at C, another one at torque BA. By using again the summation moment at X, you're able to find torque BA, which is 23,000 Newton meter. By using the torsion formula, you're able to find the radius of the brass shaft. Later, you have to times 2 to find to get the diameter of the brass shaft. Make sure you substitute the right maximum shear stress. Then you will get the value of 0.1250 meter as the diameter of the brass shaft after you times 2 with the radius of the brass shaft, which is 0.0625 meter, and this will be the final answer after you times 2, 0.1250 meter. That's it.
Number 5, we know that we need to determine the maximum diameter, also the maximum shear stress. So from this formula, we just substitute the info given from the question, so we will get the answer. But the answer is for J, the polar moment of inertia. To determine the maximum diameter, you just need to use this kind of formula. Make sure that you use the formula, diameter formula. So you just substitute the value and you get straightforward the answer for diameter. For determine the maximum shear stress, use formula of shear maximum and you will get the straightforward the answer. But make sure here the degree you need to the angle you need to convert into the radius, so you will get the right answer. That's it for question number 5.
Okay, question number 7. This question asks us to determine the largest of sigma y. First, we have to define the axis. Y positive to upright, X positive towards right. Then we define the stresses. Sigma X equals to 92 megapascal. Sigma Y we have to find. Shear stress is given 38 megapascal and maximum shear stress also given 55 megapascal. From the equation of maximum shear stress, we are able to find sigma Y. Due to the positive and negative in front, we will get two different answers. From there, we need to choose the larger sigma Y, which is 171.52 megapascal. The next question is find the corresponding principal stresses. To find the principal stress, you need to use the equation of the principal stress where you will get the two different stresses because of the maximum and minimum stresses. That's it.
Okay, for question 8, from the question given, we know that Fx is 250 and Fy is the force acting on the y-axis. Because there's no force on Fy, so it is equal to 0. So next, we have to find the sigma xy and tau xy. After that, we have to find the rotation, the angle of the rotation of the stress element. So for the sigma x, we use this formula, and then fx, it has given the fx, then we substitute inside and then get this value. And then for fy is equal to 0, so sigma y is equal to 0. And then shear stress is equal to 0 because we can see that there's no shear, the shear force and the torsional force, so also equals to 0. Then we use the top strap the clock method to find the correct angle of the stress element. So from here, I draw the free body diagram of the and the axis of the rotated element. And I we know that we already know how to find the angle, and this positive is meaning that this vertical line is swept to the inclined plane, so it's rotated anti-clockwise. So with this information, then we can use three important stress transformation equation and substitute inside, and then we get this value for this rotated element, rotated element. And then the last step is to construct the Mohr circle. Before construct the Mohr circle, we can find some information for construct the circles, which is the center of circle, radius, and the principal stress by using this formula that we have uh, learned before. So by substituting the value inside, we can use the value to construct the Mohr circle.